Can you hear me okay? Can you turn this on? Yep. Good morning. Everybody's awake? Yes? All right. First of all, I'd like to express my deep appreciation and thank you to the chairman, Dr. Watts, to the board, and to the committee that's sitting here, and to the dean of the school. Thank you very much. Thank you for the invitation, because it's through this process that I learn. And I'm a lifelong learner myself, and it's only that when I meet more people and I understand what's going on, it actually gives me a different perspective about everything. So I really, really appreciate this, and I deeply say thank you very much. Now, to the students, consider yourselves lucky. Consider yourselves really privileged. I know you're all here to listen to a lecture and to learn something. But you know what impressed me the most were the words of your chairman. When he stood up there and said, you know what, human mind is the most dangerous thing, or probably the most rare thing. You can actually figure out a way to steer it in the right direction, or you can actually, go completely rogue with it. I thought that was absolutely stunning, amazing, and also something that really came from a deep thinker, a philosopher. I really love that, because I'm going to try to relate to that statement as part of my presentation when we talk a little bit about what artificial intelligence is really doing and how this helps. So let's move to the next slide. So what I tried to do was organize this presentation into, just a few sets of components. Briefly, we'll talk about some introduction. We'll look at something called Gen AI. I'm sure you know what Gen AI means. We'll look at some of the industry and open source projects, because one of the things we have to do is, just like the papers that you guys have published already and the work that you've already done, there's a way to collaborate with a bigger community that's outside of this ecosystem. And actually, some of those open source projects are really instrumental in driving that change, that delta change. My favorite project that I've been working on these days is something called autonomous infrastructure. Now, when you say about autonomous infrastructure, I'm not talking about the physical infrastructure. You already know about self-driving cars and autonomous vehicles and all of that stuff. No, my aim is to build an autonomous infrastructure that includes telecommunications and IT that can operate elastically on demand to the needs of the subscriber, to the needs of the users, and to the needs of the type of services that you need to be able to offer. So I'll talk briefly about that particular project. But one other interesting thing that's really important in the context of artificial intelligence is what I call as autonomy and governance. And that's really critical, and that's where I'm going to relate to the doctor's statement about human mind. Without governance, without, a set of defined capabilities and rules, you are not going to be able to achieve what you need to achieve and drive it in the right direction. That is using technology for the purpose of, betterment of humanity. That's really important. So we'll talk a little bit about that, and then we'll wrap up with the conclusion. Next slide, please. So, often we get asked this question, what is the difference between analytics and AI? Can anybody tell me? And just raise your hand if you know the answer. No? Come on. I need you to be more responsive. Okay, let's move to the next slide. Next one. So, we all generate data. Humans, machines, Some of you, I just saw your IoT lab. That was really impressive. You have lots of tools within that IoT lab. And what are these? These are sensors, devices that are generating data. Data by itself, if it generates something, you store it somewhere, you won't get anything out of it if you just don't do anything with it. You can store data. You can, just put it into whatever type of storage that you have. But you won't get anything out of it if you just store it and keep it there, or if you just throw it away. The data is only meaningful when you start to analyze it. When you start to analyze it, what do you come up with? you come up with what you call as interpretations. Now, by applying different algorithms to that particular data and doing analytics, you come up with certain types of interpretations. Those interpretations drive us to certain conclusions. Now, that is what is called, reactions. So an interpretation will cause a reaction, and that reaction within our brain is that we actually internalize that and say, this is what this means. And hence, maybe now I'm open to taking an action associated with it, right? So those interpretations lead to reactions. Now, when reactions happen, you can plot something called a trend line, historical trend line. Now, when you plot a historical trend line, you say, okay, this happened, this was the interpretation, this happened, next, this happened, and then next. So now you've plotted some points. Now you're going to find the line of best fit. When you find that line of best fit, now what you can do is you can do projection. When you do a projection, how meaningful that particular projection is, that's what's prediction, right? You're predicting something that didn't happen, that did not exist. That particular prediction is where really artificial intelligence can help us. It can help us be more accurate with respect to prediction. Now, some of the oldest, strategies that we use in terms of prediction is what? Linear regression analysis. Anybody learn linear regression analysis? Yes? Somebody says yes. Thank you. Thank you for that response. Right? So we use that. We use different types of NP-complete problems. You know what NP-complete problems are? Anybody know that? Come on. You're computer science students. Okay? NP-complete problems are problems that you don't have full solutions for. There are different heuristics that you can apply for those type of solutions. Right? So based on what algorithm you apply, based on what you do, those things actually lead to certain types of outcomes. Those outcomes are those predictions. Now, how accurate they are, what artificial intelligence can really do is help us with that. So now do you get a feeling for what's the difference between data analytics and artificial intelligence? Does that make sense so far? You with me or still sleeping? Okay, next one please. Recognize this. This is not my signature, by the way. Anybody recognize this graph? Anybody seen this graph before? Yes? Somebody said yes. Love it. Give me the answer.
I think it's a graph of RedHat.
Okay, no. Good guess, but no. All right, one click. Just one click. Now do you recognize this graph? It's divided into 5 segments. No? One more click. Now do you recognize this graph? Yes? No? Yes?
I don't know for sure, but it's just from that book. Because there's a similar graph in the book Atomic Habits.
Okay.
Sort of.
No. All right. Look, one thing I have to tell you before I move to the next click of this graph. Your professors can probably teach you the best, theory, the best algorithm, the best math, and the best ability to analyze that. I cannot compete with them. I am not here to teach you that. So I'm not here to tell you what the atomic number should be or what the mathematical model should be, whether you should use, Gaussian parameters or whether you should use normal distribution or some other distribution. That's not what I'm going to tell you. What I'm going to do is I'm going to tell you how to apply what you've learned in the context of how industry takes that. And so in the industry, as you move from your college experience to an industry experience, you will need to apply what you've learned here in college in terms of how you build those mathematical models, how you interpret that particular data, how you actually take it to market. Now, next click, one more click. Now do you recognize this graph? Based on that thought, in terms of what I just described, now do you recognize this graph? Yes? No? All right. This graph was actually first published with this particular parameters by Gartner. Anybody know what Gartner is? Gartner is a market research agency. They do technology research. Implementation of technology in the market, implementation of technology in the industry, and they publish every year something called the Gartner Hype Cycle. That's what this is. Every technology that comes to market, doesn't matter what it is. It's 5G, it's 4G, it's AI, it's machine learning, it's data analytics. Doesn't matter. It goes through a hype cycle, and this is called the Gartner Hype Cycle. The first phase of the Gartner Hype Cycle is what is called as the innovation trigger. That's where innovation's happening. That's where you're building up things. You're coming up with new things. Then as that innovation happens, the industry lobbies around that particular innovation. And then everybody hypes it up. Everybody says, oh wow, this is going to solve all my problems. Right? 5G was launched a year ago in India. Did you notice a difference on your phone with respect to 5G? Yes? Anybody say yes, please? No. I didn't either. I've been using 5G for 3 years. I didn't either. What happened? It's a hype. The hype that takes it up, because now people want more investment. People want more participation. People want more collaboration. So you go through what you call as a peak of inflated expectations. And then right after that, what happens is, well, then the reality sets in. It says, oh, wait a minute, this really didn't work what I was expecting. But you know what? Then you go through what is called as a trough of disillusionment. Once you get there, then things start to become a little bit more mature. And then you start to begin to see the real value of things. When you see those real value of things, that's when you're on the slope of enlightenment. And then the technology goes into a mature phase. It's broad application, broad deployment models for that. And you go to the plateau of productivity. So every technology goes through this. Next slide, please. So now you can look at the different components of AI, where they sit in the hype cycle. Where is Gen AI on this? Notice where Gen AI is. How many of you use ChatGPT? Good. What do you use it for? Assignments? Right? What else? Anybody just use it for curiosity? Good. What type of curiosity? What are you curious about? Yes?
Basically, I like to see what all would be the responses of ChatGPT in the other conditions aligned with the company. I like to try out all the various possibilities or the questions I can ask, and then I check what all would it give. It gives for most of the questions, it gives it is reaching the company's violation and for publication policies. Excellent,
good job. Nice way of utilizing a piece of technology. So what we're doing then is, well, ChatGPT is an example of Gen AI. It's generating something new from the model and the data that it was given and that it was trained on. So you can actually use ChatGPT to write a letter to your grandma in the old English, model, right? The Shakespearean English model. You can do that. ChatGPT will probably write them the most beautiful letter. How was it developed? Large language model research has been happening in the industry for more than a decade. There were many bits and pieces of software that came well before this. Speech analysis, language analysis has been around for a long time. I'm sure we all got introduced to Siri. We all got introduced to Cortana. These are all different components of large language models, right? And they're used differently. What ChatGPT really did was provided using a public project with OpenAI, started generating new things instead of just analyzing and responding. So an Alexa, a Cortana, or a Siri is an analysis and response behavior. You tell it something, it analyzes, and then it responds back. Hey Alexa, play this, right? Now, what ChatGPT did was instead, it could create content in new form, which is where the Gen AI technology is really leading into. Now, the point that I was trying to make is now all of the things, so some of the things that you're learning, machine learning, analytics, we now have a BTech program in that. Where is that in the hype cycle? You're catching it at the right time. So for those graduates who are actually going through that, congratulations to you. I look forward to seeing you in the industry with your experience, with your learning, to actually contribute more meaningfully. Next one, please. So what are different technology trends? I mean, actually, I was quite impressed by the labs that I saw, and especially the presentation from the dean on different types of projects you've done in healthcare, and particularly using AI. Data analytics, of course, we already know about it. I don't need to tell you anything more. Machine learning and deep learning is another one that you have actually a degree program here on. You know what? Even if you're not taking that particular degree and you're still part of computer science, take a course. Even if you have to spend an extra semester, do it. You will learn something. You learn something new, something completely different. Right? It is really good. Natural language processing also we spoke a little bit about. One thing, I don't know whether you noticed on the previous slide, was computer vision. Believe it or not, 30 years ago, or maybe even more than 30 years ago right now, now I'm aging myself when I say this. 32 years ago was the first time somebody actually did a computer vision project as part of their BTech degree, in the fourth year as the capstone project. That was one of my colleagues, in Hyderabad. By the way, I'm from Hyderabad. I'm from Osmania University. And he did that project. And that gentleman, he lives in Bangalore right now. He, was recently the vice president of Accenture operations, Gopal Sharma. He's a very close friend of mine. The reason why I bring up his name is because he did that work on computer vision in terms of recognizing objects 32 years ago. He went on to do his PhD at U Michigan Ann Arbor. And after that, he started working for IBM with Watson Group. The story in this is that when he started to work with IBM and Watson, you know what he did? He started working on recognizing and interpreting object movement. Guess where that was used first? His work. Come on. What tracking? Close, but not that. Guess, come on, guys. I need you to be more interactive. On purpose, I'm going slow. I need you to talk. You know where that was used? For the first time, it was used in ball tracking. Where in ball tracking? Tennis. Ball tracking was introduced in tennis first, to actually find out if the ball was over the line or not. After that, where did it go? Cricket. You know this DRS system that we have today in cricket? That ball tracking, that was his work. Baseline work, his original work, in terms of object movement and tracking. What do you do there? First you analyze where the object is moving. Then you build a bunch of parameters into it, the rotation, the spin, the speed, the direction. You have multiple vectors. You take those multiple vectors, you analyze, then what do? You predict. Right? Isn't that what DRS today is? By the way, how many of you have a complaint about DRS? It never works. It doesn't show the proper spin. You all have heard the pundits on the TV, right? But it's an amazing piece of technology. Where did it start? It started with computer vision. Where was computer vision on my previous slide on the hype cycle? Almost to the plateau of maturity. What I'm trying to tell you is sometimes it takes some technologies a long time. Sometimes it takes some technologies a really short time. Computer vision is now extensively used in quality control, in production lines. You don't even know. You want to figure out there's a hairline crack in that aluminum sheet. You're not going to be able to detect it. You're not going to be visually inspect it. You can use computer vision to do that. You can use infrared vision to understand if there is a problem in the aerospace industry, right? To detect material degradation. So those are different areas. Of course, you already know about industrial automation. I think we briefly spoke about that. And you are doing some really good work in healthcare, so I don't need to probably talk about this. But drug research is another big area where now AI is increasingly being used, in particular to provide predictions on clinical trials of drugs. Drugs go through a development phase, a clinical trial phase, and then they go through, the actual, then they get approved, certified by the FDA, and then they actually go into production. So the cycle, why do drugs cost so much? An Alzheimer's drug or a cancer drug or an HIV drug, why do they cost so much? Because of the research expenses, exactly right. The amount of expenses that, the amount of time and effort that's required to develop a drug takes very long time. Even the clinical trial component of that is at least 2 to 3 years before, and then they find out, oh, guess what? This drug didn't work. And then everything goes down the drain and you start again. So because of the amount of money those drug companies spend, they need to have certain amount of return on that. And that's why that becomes, it's very expensive. So what did the law do about that? They said, okay, you can hold that drug patent for a certain number of years, after which the patent is generally available so that anybody can do it. So that's why it takes a long time for the drug that's available in the market first to the time that it's actually a generic version of it is available. Now, if you can shrink that time to a smaller space, what will happen? Exactly. It will allow availability of drugs to people sooner. These are the places where artificial intelligence can really, really help. Adaptive learning. Right? How many of you have heard of the word dyslexia before you saw the movie Tare Zameen Par? No? We didn't know about dyslexia. I didn't, at least, until I landed in the US. And that was another 27 years ago. I didn't know what dyslexia meant. I just thought, oh, somebody didn't pick up what the teacher's teaching. And then, of course, there was a movie and everybody's now aware of it. But the point I'm trying to make is, can we actually create a system that allows you as a student to learn, and increase the complexity of what you learn and adapt to your learning pace? So rather than you go sit in a class and the teacher throws, something on the wall and all of you have to do it and you do the assignment, you walk away, have you really learned? So can we actually introduce new capabilities, new methodologies, new processes, and use artificial intelligence to actually create a model that allows students to learn in a better way? Collaborative research is another one. Last example I'll give you is in consumer space. Can anybody give me an example of how AI works in consumer space? Especially I'm interested in those students who are third-year students in the, AI's degree. Yes.
The data which is on which the AI trains, it actually tries to figure out what are the favorites or the choices which the consumer has. Like we know about Netflix, the mechanism of the Netflix, it shows us suggestions. Those are based on the likeness and favorites of the person which is viewing.
Good.
So that data collection and all,
Good. What is Netflix really doing? What is Facebook doing? What is TikTok doing? What is Google doing? It's keeping track of what you do historically, and it builds a profile of what you do, and based on the profile, it's now guessing what you think you will like, what they think you will like. That guessing is where they apply their algorithms, their learning algorithms. So they're learning based on your random selection of videos to begin with. And if you want to really do something and experiment yourselves, do the following. Delete your history on the browser, right? Delete all the cookies. Go to YouTube and turn off the history of YouTube. First, delete the history of YouTube. Turn off the history of YouTube. And now try to open YouTube every time. What is it going to do? It's going to give you a random selection of videos on YouTube. And funnily enough, that random selection of videos changes not with your machine. It changes with your location. And then you start clicking on those videos, then it starts to build a profile again. And the next time you open the computer, it'll show you something which is related to what you clicked on. Now, cheat the system. Click on some, random sets of videos and then see what happens next time you close the system and you open it. And then delete it again and try to start all over again. It's a very interesting experiment. You can actually figure out what Google is really trying to do. What YouTube is trying to do. It's trying to optimize for itself. It's trying to see how many eyes can they get, how many clicks can they get. Based on that eyes and the clicks, what do they do? What do they do? Ads. They monetize it. They monetize that particular piece of information. So they are optimizing it for themselves. Now imagine you as a student, as a researcher, as a degree holder, now start to work on something that can actually optimize content for you. Can you do that? I'm sure you can. That's exactly, these are the examples, these are the areas, these are the work, where AI can be really, really helpful and beneficial. Let's talk a little bit about Gen AI next. So if we take Gen AI is really a subset of the overall AI field. Within the AI space, you got analytics, then you got machine learning, then you got something called deep learning. Anybody familiar with deep learning? Yep.
Deep learning is basically processing information as humans. In deep learning, we use neural networks as we have in our brains.
Great. Fantastic answer. What is a neural network? Can't hear you, sorry. It's okay.
It has some hidden layers.
Okay.
Which are made up of multiple neurons.
Okay. Good. That's a good answer.
So it is a connection of artificial neurons, like we basically pass the data which is passed to the artificial neuron, and each of the neuron processes it differently, and the final combined result is then provided to the user.
Fantastic. Thank you so much. So it is basically a collection of what we call as quote-unquote artificial neurons, right? An artificial neuron mimics brain neuron behavior. And that brain neuron behavior, what do? How do you store, how do you have a memory in the brain? It's basically a connective pattern of neurons. That's your memory. Neurons can connect in many, many different ways through electrical signals, right, in your brain. And you create something, and you create and you store it. And something gets now triggered to evaluate that. You can actually replicate that same pattern with something called neural networks. And that's, you just now saw some very good explanation of what a neural network is. Funnily enough, the work on neural networks has been going on for 30 years. And even more. Guess where first neural networks were used in? It's a field, it's something that I'm going to relate back to what you guys do today. Neural networks were first used in VLSI chip design. What was the problem they were trying to solve there? Placement optimization. Yeah? In VLSI chip design, very large scale integration for semiconductors, you got to pack more and more what? Transistors on the chip. When you pack more and more transistors on the chip, what are some of the problems that you run into? Heat, routing, what else? Discharge problems, leakage currents, right? So what do you have to do? You have to actually place these components in such a way that you minimize that. And as chip design shrinks, in terms of going now from 0.9 to 0.7 and so on, it becomes a much more complicated problem. So optimization and placement of those different components on the wafer becomes incredibly critical. And you actually use neural nets to model that. That's where we started the whole neural net theory. Now we're using the neural net theory in a completely different context. So isn't it amazing that technology gets developed for a certain thing and now you start to apply it in a completely different direction? Next one, please. Now here's some application of different Gen AI in different components in the area. In the high-tech, banking, pharma, education, healthcare, insurance, manufacturing, consumer goods, etc., etc. And this is actually a slide that was done by, it's one from one McKinsey study in terms of the economic report for AI. The point I'm trying to make is there's a broad application of AI in different industries. And you can potentially take any sets of problems and apply the technology to solve that particular problem. Next one, please. And here are some other examples of Gen AI. Text generation, I'm sure you've experimented with other things such as image generation. Anybody experimented with image generation? Yes? Found something interesting? No? Expected, unexpected? Yes?
I use Midjourney to create posters.
Posters, yes. It's actually a very nice way to do it. Anybody used it for code generation? I'm sure you guys use ChatGPT for code generation. Did it work? How good was the code? Mm-hmm.
Initial generations were good, but now whatever it's generated based on library and it's not that good.
Okay, that's interesting. That's an interesting observation.
The code is as good as the problem.
Right.
Depends on the prompt you are writing.
Have you found that it changes as you provide more input? You can fine-tune it. Yes, you can fine-tune it. What does that tell you?
Like the more the number of parameters that you give it, and the better and the more classified the information it will do.
That's one. What else does it tell you?
It's learning.
Learning, it's learning, right? First, it's just not about the quantity of parameters, but it's also becoming better and better over a period of time, right? It's evaluating that, it's becoming better over a period of time, and it's giving you better responses back based on what you've expressed. So where is this really taking you to? It's taking you to, what Gen AI really does is look at what is the intent of the question. And can I answer to the intent of the question? Otherwise, what you've been doing is what? Action reaction, right? Question response. You input something, you get an output. There are many, many tools that are available today that actually do that. What does Grammarly do? It checks your syntax. Basically a simple tree, you check it and you say there are certain set of rules, it checks against the rule. You violated this rule, no, you can't do this, here's a suggestion I'm going to do. Simple way. You can build actually your own parser, a parser tree for language. And you can actually build your own Grammarly if you want to. You can do it, it's not too difficult. It's just laborious. You have to work at it, but to achieve that accuracy that Grammarly provides is going to take you time. You can build a 70% accurate model easily. To get from 70% to an 80% accurate model, it requires some effort. From an 80% to a 90% accurate model requires a lot more effort. And from 90 to then 99, it's huge amount of effort. What I was getting to in terms of the example that I gave you was, the model is really important. And a small delta incremental, improvement in the model can actually have a significant impact on the output. And that's what you should be thinking about. That's what you should be, really worried about. Then there are several other things: anomaly detection, data augmentation. I don't need to probably tell you some of these are, compliance checks. This is an area of a lot of work that's happening in terms of compliance, analyzing contracts, analyzing documents, analyzing, language, because now you have an LLM model, you can analyze language and you can tell you, hey, this contract is flawed. It doesn't work. How many of you really like the contracts the lawyers actually put up? Do you really understand it? Although we all have a technical degree, me too, I never ever understand what the legal language is. And what is it really trying to say? But if I had a tool that would actually, if I could just input my contract and say, hey, am I protected through this particular contract? The answer is yes, great, I can trust it. Correct? Next one, please. So those are some interesting things, but there are also some challenges associated with Gen AI, and we'll talk about those challenges later on, right? So all of these different, benefits that you see in terms of content creation, cost-effective optimization, route optimization, anomaly detection, rapid prototyping. Another place where AI is rapidly being used these days is what is called as digital twin. Anybody heard of that before? Digital twin. So what you do is you actually create a twin of the physical space in the virtual world. Anybody do Second Life? Gaming? Come on guys, admit it, it's okay. No? Nobody knows what Second Life is? Second Life was the first version of, a virtual space. Nowadays, of course, there are so many other games, Sims and this and that, that's used. And of course, now you can use, all of these PS4 games, and you can see all of that. Anybody into gaming here, first of all? Raise your hand. 1, 2, 3, okay. So you can create a virtual space that mimics exactly the physical space. The idea of creating that particular virtual space is to provide familiarity, train people. So let's suppose you have a hazardous environment in a factory floor. You want to be able to train the person before the person walks into the factory floor without actually causing any accidents. You can actually create a digital twin of that. You can do analysis. You create a tall structure, create a digital twin of the tall structure, run it through the environmental conditions in the digital world to understand what happens. What's the sway? What's the movement? What's the, are these elements that are going to understand the stress? Can they take that? You simulate it. And then when you simulate it, then you can actually then implement it in the physical world. So that's actually really an interesting area of work. And there's a lot of innovation that's happening in all of these different spaces. There are definitely a lot more challenges and concerns as well in the context of AI. Over-reliance on these. Where do you draw the line between where your mind is? What do you think with your gut feeling, with your logic, with your capability? And where do you actually now allow the machine to take over and run with it? So things like, misaligning expectations. Now people say, oh, AI is going to take all of my jobs away. I don't know. How many of you believe that, first of all? AI is going to take all of my jobs away. A few do, yes. Look, what happens when any new technology gets introduced? Right? Fear, exactly right. Our first gut reaction is fear takes over. And then we try to understand that piece of technology and then look at where it needs to be implemented, how it needs to be implemented, and then we take that, and then we come to terms with it. So you find what is called as an equilibrium point. That equilibrium point is important, and then something new gets introduced, and you start to move again, and then you find the next equilibrium point. That's really critical. So no technology, you can actually say, well, it's going to be completely bad. You really have to understand the implications of it. And then you have to understand how to adapt and how to adopt. Difference? You need to learn first how to adapt to it, and then you need to learn how to adopt that in your work. Next one, please. Let's briefly, very quickly talk about some of the different open source projects. I actually see that you're already working in some really interesting areas, particularly around healthcare and around using AI for certain components. Next one. There are several different open source projects that are happening. What I encourage you to do is participate in those open source projects. Even as a hobby, sit in those meetings. If there is a way you can attend those meetings, if there's a local hackathon that's happening, go participate in that local hackathon. You can code, you can be part of the hackathon. It doesn't matter what they're discussing. It matters that you learn and get that exposure for yourselves. That is critical. You can get involved in an open source project by not necessarily contributing to the code. You can get involved in an open source project just by providing some help around documentation of that particular project. You'll be listed as one of the contributors. So there are different such type of open source projects: Kubeflow, MLflow, PyTorch, TensorFlow, Jupyter, Spark, Operator Hub. Actually, if you haven't done it at all today, if you don't know about it, go look at Open Data Hub. Open Data Hub is an excellent project where you can actually get ML as a service, machine learning as a service. It's based on some components that RedHat is invested in. Doesn't matter whether RedHat or no RedHat. I come from RedHat, but that's okay, right? Kafka, messaging, Jupyter Hub. You know what Jupyter Hub is? What Jupyter Notebook is? Yep. Good. So, and Spark, Apache Spark. So it's actually, a curated data set, anonymized, that you can actually use to look at how good your model is, or to train your model. Use it. All right? Next one, please. And these are some other various different projects: PyTorch, TensorFlow, Keras, Open. There is an OpenAI's GPT API. One is, of course, you use through their interface in terms of ChatGPT. There are APIs available. You can use that API with your own data set and actually create create an app yourselves. Don't wait, do it. Right? Apache MXNet, Microsoft Cognitive Toolkit, next one. And then there are other things such as FastAI. How many of you played with OpenCV? Anybody played with OpenCV? Yes, what did you do with it? Yep. Facial recognition. Good job. What did you do with it? Back, last row. Yes. You did that also. Anybody tried object tracking with OpenCV? Yes. What happened? Okay, good job. I would urge you to try it. It's very simple. It's very easy. You got Python, you got libraries there, use your own webcam, load it, and you can play around with it. And then set it up in your dining table. Whenever your grandma walks around, you can recognize grandma's face and say, "Hi, grandma." I'm sure she'll be delighted. I'm sure she'll get a smile on her face. The point I'm trying to get across to you is, there are tools, they are very, very simple. You are in this domain, build it, learn it. Don't just rely on what's in the textbook and what's in the homework assignment. You will get far more experience from that in terms of building it and learning through this process. Next one, please. Now, there are different projects that are there in terms of the public cloud. If you have access to them, I would encourage you to do this. I don't know if there's a program here from the university to provide, some collaboration with public cloud, whether it's AWS, Azure, or Google, but they have different toolkits. Those toolkits are what the industry uses. And if you have any exposure to those toolkits, even brief ones, even if you have a higher level understanding of what that toolkit looks like. It helps. It helps tremendously in terms of jump starting as soon as you walk into the industry to say, well, I've used this particular toolkit. So there's one with AWS, there's another one with, next one, please, Google, and there's one with, Microsoft Azure as well, next one. And there's also some NVIDIA, next one, please, with those. These are all different toolkits based on their code, their libraries, their capabilities, right? That you can leverage very, very easily to build and to create in terms of what you want to do. Next one. Watson also has this. Watson has something very interesting called Watson Assistant. It's a beautiful toolkit that actually, I'll give you a very interesting example of this particular toolkit. You can take this lecture that I gave you today, feed it into the Watson Assistant. You have a recording of it, feed that entire lecture to the Watson Assistant. Go pick up some of my quotes from the newspapers or the magazines or the blogs and the articles that I've written. Feed all of that into Watson Assistant, right? And then what Watson Assistant does is something very dramatic. What it does is it analyzes all of this information. It analyzes my speech, my writings, my public capabilities that I have shown, my videos that you have fed, and it creates a map of what do I care about. So if you looked at that particular map and understood what I care about, it would take you no more than 10 minutes to actually have a conversation with me that is meaningful to both you and me. That's absolutely stunning and amazing. Do the same thing with your chairman. He's accomplished, he's distinguished, he's spoken at many places. Next time you want to walk into the chairman's office and you want to ask for something, if you can frame that conversation in less than 3 minutes for the chairman, would that be impactful? Yes? Would that be impactful? These are some amazing capabilities these tools provide. What I need you to do is be curious, be inquisitive. Go learn, go figure this out. Right? Next. Of course, you can use this for some novelty as well. ChatGPT, Cleverbot, DeepArt, doodles, memes, all of those things that we've all seen. Next. Here are some interesting challenges associated with AI. Deepfakes. Deepfakes are really dangerous. Deepfakes can create, there was actually recently a very deepfake that was circulated that actually spoke in Joe Biden's voice and said something that Joe Biden never said. So what they did was they fed a text message, Joe Biden's voice samples, and now it could generate new content in Joe Biden's voice, and there was an audio message. That's dangerous. Right? So these are some things that AI, if you use technology for the wrong purpose, that also happens. Ethical considerations, bias. Bias is a huge topic of research in AI today. What creates bias? Come on guys, wake up. What creates bias? Yes?
Personal experiences and whatever biases that we already have in our, according to us, get incorporated into the AI model that we are currently developing.
Fantastic. Right? Human bias that we have, conscious or unconscious, we have both type. A conscious bias is because of our upbringing, our training, or things that's a conscious bias. Or sometimes our gut instinct tells us to be biased in a certain way. That's a conscious bias. Then there's an unconscious bias. The unconscious bias is, something that we don't know we have, but that has an impact on the society, right? That can translate into machine learning models as well. So on that machine learning models, that could be really dangerous if artificial intelligence was biased, if you started to racially profile all black men who walk on the street, like we do today as humans, if a machine started to do that, that could be extremely dangerous. Because now, after that, there is no point of no return, right? So, things like discrimination. How do you build transparency into this? How do you build accountability, and how do you build regulation? So these are different challenges, and there's a lot of research, there's a lot of activity, there's a lot of work going on in this particular area. You can pick up any one of these topics and be a hero, really, because it requires thought, it requires analysis, it requires experience, and it requires, something that's only a human possesses, a moral compass. A machine doesn't possess a moral compass. That's a big difference between a machine and a human. I think the chairman said it, compassion. The word that he used was compassion. Who has that compassion? A human has that compassion, a machine doesn't. So that's only a human can influence and change. Next one. All right, so this is very, very briefly about a project, and I'm going to wrap it up in less than 2 minutes. It's something that I've been working on called autonomous infrastructure. When you build an autonomous infrastructure, you need to analyze a whole host of data associated with that infrastructure. So first you analyze, then what you do is you do something called, next one, you do something called automation, hyper-automation. So what is an autonomous infrastructure? Zero touch, zero deployment, operations, and it's self-configuring and self-managing infrastructure. That's what I really do for a living. That's part of my job. Next one. So what you do is first you automate. You instrument, you automate. When you automate, then you analyze, and you apply AI to that. And then you use autonomy and governance to actually build it. Next one. So what we do is we do this work in terms of the infrastructure management closed loop, where you can drive those decisions to actually start with observe, analyze, react, and then change, right? So you create a complete closed loop. And then you apply intelligence to that particular model. That intelligence gets distributed, and that now you're able to actually intelligently operate an environment where you can build elastic infrastructure. You can, anytime there's no requirement, suddenly the infrastructure grows. Then the requirement goes away, it shrinks. So you can create that level of elasticity in terms of that particular infrastructure. Next. And then you can do, and the only way that's possible is automation. So one of the things that I'm going to tell you as school graduates or school students is focus on learning how to automate tasks. Whether it is code generation tasks, whether it is business operation tasks, whether it is, infrastructure management tasks. If you learn automation, that's your key to success in terms of being a better data analytics guy, being a better data science guy. Next, or girl. We'll skip this one next. So I think we spoke about most of these use cases in terms of predictive analytics, self-organized networks. These are the areas that I've been working on. Self-organized networks, self-tuned, infrastructure and campaigns, AI-assisted customer service and bots, DevSecOps, traffic security planning, right? Automatic network configuration, and those type of things. So these are the areas of my work. So if any of this interests you, feel free to reach out to me. Next. Let's switch. So one important topic that we need to think about, next one please, is autonomy and governance. How do you provide autonomy, and what's the level of governance you need in the kinds of data? Your chairman really said something really important. It's your mind can think and go anywhere. You need to figure out, sandbox it, and what happens to the mind, you can think about something, but that's really, it stays with you until you act upon it. It's really critical for you to understand that. You can think about any kind of thought, good, bad, worse, brilliant, but it still stays in your brain. It doesn't go out. Once you start to act on that thought, then now it's applicable to the rest of the society, to the rest of the universe, to the people around you, to your ecosystem, right? Now, how does a machine, what level of control or governance do you provide to that machine? so that that can now have an action or capability, right, and an impact in terms of the action. So to do that, we look at business operations, service operations, resource operations, and think about what frameworks can we create. And how do you create that particular framework so that you can provide the right governance? Next one. And you can understand what's the level of autonomy that you want to provide to those machines to operate. Remember, I told you my project was intelligent autonomous infrastructure. I want to know what level of autonomy do I want to provide to that particular infrastructure so that it can take its own decisions and act and react the way it needs to. And it's important because I can't let it go rogue. I can't let it use maximum amount of electricity and draw power from everywhere. I have to provide certain rules, certain parameters, certain governance, certain sandboxes. Next one. So we have this particular cycle in terms of how we can create AI-driven operations, smart operations, and monitoring and event management. One of the big areas of work is around energy savings in terms of AI. There's a project called Kepler. If you remember something from this lecture, notice that particular project in terms of how you do analysis of data and information to provide better infrastructure that provides power savings. If you save 10% of the power, 20% of the power in terms of data centers, how much impact does it have on the society? Next. So what's the future? Where does this lead to? Lots of questions, maybe not as many answers. I expect you to go discover those answers for all of us. Where's the conscience? Where's the ethics? Where's the morality? Where's the autonomy? And what level of governance do you need? These are big questions. While there's technology, there is research. Technology can be used the right way to the betterment, and technology can be used the wrong way. The example the chairman gave you in terms of what's happening in Ukraine, what's happening in Palestine. It's being used the wrong way. So we need to think along those lines. And I would urge you, especially all those seniors, the 30-year students, to think about if you want to go into public policy at some point in the future. What would you advise if you had the minister's ear for 10 minutes? What would you say? Think. I need you to think. Next. So we see a host of benefits. We see different use cases, particularly in the area of cybersecurity, fraud prevention, fraud detection, quality control, public safety and security. All of these places AI can help, and there's absolutely huge potential to tap. So congratulations to all of you who are doing programs in this space. Really, this is the future. That's what you're really going after. I need you to pay attention. I need you to learn, and I need you to actually do something for the sake of, for the betterment of your colleagues, for the betterment of people who come behind you. There are different areas that's being applied to in terms of manufacturing, cybersecurity, quality control, climate and environmental problems. We all saw that, and energy consumption. What should be the governance and what should be the policy for a country like India? You can come up with that answer, and that's where I think Uday is going to, take over. So thank you very much. I appreciate your time. Really.